Okay, great. Thank you.
And so let me introduce you. Sorry, I should have. I think probably everybody knows you, but Eric Bellm is in charge of the alert system as alert project scientist. Is that the right title?
Science lead for alert production.
Alert production, exactly. And so he is giving the alert stream talk today. Thank you, Eric.
Great, thanks, Fed. So as advertised, I was asked to give an overview of progress on the alert stream. What I want to talk about today, as well as answer your questions, want to just start with, again, the high-level overview, make sure that we're all on the same page in terms of what LSST is providing. I think that's well understood, but sometimes the details get a little fuzzy. I'll describe a little bit briefly some of the technologies we're working on in data management to deploy the alert stream. I think we've made some pretty good progress there. And I'll spend the bulk of the time talking about something that I'm calling a broker policy document, which is a public-facing document that we're preparing to, especially to describe the process for selecting community brokers, but more generally to provide a sort of a single resource for people who are thinking about time domain real-time science with LSST, both with the alert stream and community brokers, as well as with the LSST provided MiniBroker, about which I'll also have a few words to say at the end. So again, just to set the context, the prompt processing system, which historically has been called the level 1 system for LSST, is really focused on enabling real-time science. So we take an image, ship it up to the data facility, perform image subtraction, and identify everything on that image that is above a threshold. And so in particular, it's finding things that are moving or varying. And then we take those sources and put them into alert packets with a bunch of other information, historical lake curves, the image cutouts, time series features, connections to the data release objects, data release production objects. Put that all together into a really fat alert packet and ship them out to the world. But the world in this case really means sort of a finite set of community brokers who are receiving that full sort of terabyte scale stream, and then potentially adding additional value by cross-matching or performing classification or adding other sorts of contextual information, and then providing user access to that stream. There's
Eric,
also, yep, go ahead.
can you put your slides in presentation mode? They may be a little bit bigger, and I'm not sure what screen everybody has available. We see your screen, we see the slides, but they're in presenter mode as opposed to viewer mode.
So I should just swap this display like this. Is that better?
Yes, thank you. Yes, thank you.
All right, sorry, it's the usual multi-screen makes it hard to tell. Okay. So in addition to that full stream that goes out to the community brokers, there's also a filtering service, which we sometimes call the MiniBroker, that runs in the LSST Data Access Center. It's restricted to data rights holders, and that enables users to upload sort of simple filters that just act on the alert packet contents, but is a very sort of flexible and sort of low-key service that's also available. So I think it's been very clear that there are lots of open questions about how this all will work in practice. Some of those, I think, are things where the LSST project thinks we know the answer, and it's a matter of getting that information disseminated effectively. But there certainly are also areas where there is not a well-known answer. It's not been decided for either technical or policy reasons. And so what I'd like to discuss today is some progress towards dealing with some of those open questions. I have some concrete suggestions, and one of the, I think, goals of this particular talk and discussion is to get your feedback so we can course correct as needed before we start making this announcing it more broadly. Okay, so starting first again with the update on the technologies. So again, we have to ship 10 million alerts a night with that 60-second latency. It's about a terabyte of data, and we have to include the cutout stamps. These are all things that are in our requirements documents. So data management has judged that the existing sort of view event tools are not sufficient for doing all of that. And so we're focusing on sort of what we're calling a bulk transport system that's really meant for handling the few full streams to community brokers, as well as some of the internal alert handling, for example, in the MiniBroker. So we're building on a suite of open source tools developed by some of the commercial internet providers, in particular Apache Avro, which is a binary serialization format. Apache Kafka is a real-time queue system that has some very nice properties in terms of scaling and streaming. And then we're looking at ways to use Apache Spark for things like the filtering layer, but that's still a work in progress. So in terms of distributing the full stream, we've done tests that are detailed in a data management technical note, the link of which you can see on the slide, that shows that we can indeed achieve the performance that's required for LSST using these technologies. So we're satisfied that we can meet the scale needs that we need with this system. We have a formal NSF recognized milestone for alert distribution in July, and I think that we should be comfortably able to meet that. Finally, I should mention that there's a fork of this technology stack has been adopted by another survey, the Zwicky Transient Facility, or ZTF, and they are using it for their own internal alert distribution and preparing to provide a public feed intended to be analogous to LSST's later this year. So the hope is that some of that experience will feed back to the LSST project so we can assess any limitations that we might need to be aware of. So I want to turn now and talk about the broker policy document, which again is intended as a public-facing document to collate a lot of information that I think is a little bit scattered, and for the average user or average scientist who's maybe not quite as adept at digging through DocuShare, sort of collect all the information in one place. So we're particularly focused on science users who might be thinking about how they can do science with LSST in a few years, but also folks who might be thinking about developing community brokers and wondering what might be required of them and what the timeline is. Implicitly, there's also, I think, an audience at the funding agencies to understand what LSST is and isn't providing and how they can support the larger time domain ecosystem. And I think it will also be of use to the LSST project. So we have a draft that we are sort of well on our way with, entitled Plans and Policies for LSST Alert Distribution. The goal is to post that on the archive after it wins its way through the approval process. I'm expecting that we'll have a draft to the various stakeholders in June, and the goal would be to have a full release at the all hands meeting in August. So therefore, yep, go ahead, Fen.
Is this document going to be released internally to the science collaborations before that deadline, or yes, when it becomes public?
Well, so I would expect that the science collaboration chairs would have a chance to take a look at it in that June timeframe. Yeah.
Thank you.
As well as, of course, the PST and others. Okay, so the document has 4 sections, which I'll go through in slightly more detail. The first is sort of reviewing, again, as I just did, what the LSST alert distribution system is, what are the parts, what are the bandwidth limitations. There'll be a little bit on data rights. That's mostly handled by another document, but it's useful to summarize here. There'll be a big section on guidelines for community brokers, outlining the proposal process we envision. And I think it's also useful, particularly for science users, to describe the MiniBroker system, what that does, and how it might be of use for their science goals. So again, the first section is just summarizing what we're building, connecting, just a high-level summary with links back into some of the more detailed design documents and requirements documents for those who really want to dig into the nitty-gritty. And so a lot of the sort of basic questions like, what's in an alert packet and so on will be dealt with here. Some of the questions I think that we'll need to address that are not fully specified is, exactly what happens, for instance, in crowded fields. We have a requirement to deal with up to 10,000 alerts, but it's not specified what happens after that point. So there's an example of a case where there's a sort of a feedback between the technical capability as well as the formal requirement. So clarifying issues like that is, again, something that I think this is a good place to provide. The data rights section, again, is summarizing what exactly a user can expect, whether they're a member of the US or Chilean communities or international contributor, or if you're part of the scientific community in the broader world. In general, I think the short summary is that the contents of the alert packets themselves are world public and hence can be freely redistributed. But basically all the other components are going to go through the LSST Data Access Center and hence will require data rights. And in particular, that includes the MiniBroker, for instance. So a couple of points, for instance, that we might clarify here is just to emphasize that, scientists without data rights will expect to access the stream through community brokers, for instance. We do expect to allow community brokers to reach back into the DAC. For instance, if they wanted to retrieve additional information or get a larger cutout or a template, for instance, that there'll be a requirement that they be able to enforce the data rights for the products that they return to their users.
This is Michael Strauss. That sounds awkward or challenging, or I'm not sure what the right word is, because the way in which that enforcement happens, I don't know quite how we give people the tools to make that possible. And the rules for who has data rights are complex. And if people are not extremely careful about this, they will be giving out data that they're not supposed to. And I'm not sure we're giving those people who are writing community brokers the tools that they'll need to do something sensible here. I don't know if this is a concern.
I think it is a concern. Yes, I agree that this is something that DM should clarify further. My expectation has been that there is a sort of single sign-on authorization mechanism that the science platform will support that could be adopted by community brokers. But I agree that the devil is definitely in the details here.
Yeah.
Okay. So next, I want to touch on the section about guidelines for community brokers. This will be one of the longer sections here of the presentation. I should emphasize that these are suggestions and ideas in particular, and so I welcome your feedback. I think many of the aspects are straightforward, but as always, there may be specifics that have escaped our notice so far. So the goal here, and really motivating the whole document, but especially this section, is to lay out clearly how the LSST project intends to select community brokers. Again, to remind you, because of the scale of the alert stream, we expect to be limited by bandwidth out of the data center to a finite number of full streams to community brokers. Historically, I think that the provision has been for about 4. That number is somewhat uncertain. I don't think it will go down, but it could go up a little bit. but we don't yet know an exact number, and won't for some time. So accordingly, that suggests or implies a means of selecting who can get a full stream, and that's the process which I'm outlining here. I should emphasize that there is an expectation that there will be some degree of support needed for community brokers from the project, and that also weighs into having a selection process just to keep that problem sort of bounded. I will deal with these sort of italicized questions in more detail in the next slides.
Eric, before you go on, can I ask you a question?
Sure. Go ahead, Chris.
Why is it, this is Christopher Stubbs, why is it a given that the project decides which community brokers will be chosen? I could imagine a scenario where the project dictates boundary conditions and technical criteria, and it's not clear to me whether the project has appropriated that decision.
Right. So I apologize. I think that I think I missed a slide that I've had in previous versions of this. I don't actually see the project making the selection. What we're suggesting here is the evaluation criteria, and I would expect that it's likely the SAC or its delegates that would actually be responsible for the selection. But I think that's a topic which is certainly under discussion.
Okay.
So in terms of selecting brokers, our suggestion, and I think Chris definitely raises a good point about scope here. We're bringing suggestions to the stakeholders for feedback. We're suggesting a fairly open call for proposals, with basically only a requirement that a community broker proposal demonstrate that they can in fact handle the full stream, or in terms of hardware. And so we're not in particular expecting to levy strict requirements to even receive the full stream or redistribute the full stream or make the products world public, although the criteria we're suggesting will favor those proposals that offer those. And the goal of making this a fairly open call is to really enable a sort of a rich cross-section of proposals that can generate the widest variety of science. Our expectation is that different institutions around the world have different strengths and strategic interests, and trying to force everyone to build the exact same type of broker is perhaps not useful. So, this is a judgment call, and I think at one area in particular where I think your reactions are useful.
So the subtext, if I may, the subtext here is that you expect that there will be at least a few brokers that will, in practice, serve that broader community and will make the products world public. And so it's a logical possibility that won't happen, but you imagine, knowing the ecosystem as you call it out there, you imagine that there will be some that will be fairly broad in that sense.
Right. My expectation is that, again, with the criterion we're outlining here, that there will be motivation to for at least a few brokers to step into that role. I agree, it's not a guarantee.
Okay. And again, any institution worldwide can propose. So one does not need data rights to be successful here, and yet those who don't have data rights would still have access, as you said in the slide a few slides back, to the full LSST database to put their objects in context. Did I miss that?
So the statement would be that a broker would be allowed to reach into the DAC if it was limiting the distribution of those products to data rights holders. So I wouldn't expect, if an institution was proposing for a broker, I would not expect them to be building DAC-specific services because, a large subset of, I guess it's hard to say. There's no reason that they couldn't, I guess, but it wouldn't make a lot of sense to me, if their own users were not able to access DAC services for them to spend a bunch of effort building that capability in.
Okay, good. We'll just have to make that super clear in whatever goes out.
Yeah, I think to rephrase this statement maybe a little more clearly, being selected as a community broker does not grant DAC access, but if you have DAC access, you're able to use that.
Mm-hmm.
All right, so as advertised, the major sort of initial gate is demonstrating that the proposer has adequate technical resources to do what they're promising. So that means lots of network bandwidth, given the scale of the alert stream, lots of disk and database, computing, but also certainly the sort of personnel and institutional support you'd expect for, an archive type data center. So this is really just, trying to make sure that we're considering serious proposals as you'd expect. So we're suggesting that the SAC appointed committee would look to the scientific utilization that the brokers would enable. Some factors you could consider here are the size of the community that's served, the importance of the science, if there are unique capabilities that a proposed broker was offering, and in particular in the context of LSST science pillars, as well as something that takes advantage of the unique aspects of the alert stream, namely that it's real-time and world public. So I think there are certain types of science that really require that, and so those are natural science cases for brokers to serve. So the criteria that we suggested, and again, these will be blessed, I think, by the appropriate bodies in due time, is again just making sure that the proposers are adding scientific value. Again, we'll encourage selection of brokers that are serving their products to the world community. Want to make sure that the data products that are presented are valid and correct, which could be demonstrated on precursor surveys or data. There's, I think, a role, at least for some brokers, to integrate more broadly into the time domain ecosystem in terms of, for example, triggering follow-up telescopes or integrating with other archives or services. Obviously, if there are brokers who have prototypes that are running today and they're being used by the broader community, that's, I think, a strong signal. And I put as well complementarity here, which is to say I would hope that the selection committee, when evaluating and choosing a final set of brokers, would sort of look to the sum of their capabilities in terms of, again, the science that they're enabling, the communities they're serving, rather than, for example, just stack ranking them and picking 3, supernova-focused brokers and leaving all the microlensing folks out in the cold, for instance. And finally, I just want to flag here that in some cases there may be existing agreements that the LSST project has that may prove relevant. So the timeline, I think, is another area where your suggestions are welcome. Again, we're aiming to release this document later this year. And then next year, I think potentially would be the earliest we could imagine the formal call for proposals. There's some things we need to do before then in terms of documenting our formats for bulk transport, as well as setting up some tools so that proposers can practice and work a little bit and understand the format of the stream. The sort of walkthrough here then would have proposals due in 2020, which is about when we're starting work with ComCam. There will be alerts from ComCam, but we're being encouraged to advertise them as coming with substantial latency. I think that means weeks, not days. In 2021, then we would use that information from ComCam to really understand the false positive rate, the performance of the pipelines, and hence, the actual bandwidth we need to transmit the stream, and so could then select an actual final set of community brokers while we continue commissioning. And so then that would give us a chance to integrate those brokers ahead of formal operations. So this is the schedule I'm suggesting, but I think there are arguments for and against shifting those dates forward or backwards. Obviously, earlier selection is better for brokers who might need to secure funding, and so having a guaranteed selection would aid that. Again, I think there's still enough uncertainty in terms of how many brokers we're able to support, and just generally allowing the community to gain experience and prepare, which would tend to push towards a later selection. But again, I'm happy to take thoughts and suggestions here.
So I'm going to report that I have heard this concern by several people that are involved in various broker planning and brokers construction about the fact that if the finalization is 2021, they don't think they can support funding until then, on the premise of the fact that maybe there will be a selected broker.
Right.
And I don't have a suggestion though, because I realize the complexity of the issue. And then I have a question about the 2020, the point about 2020 and ComCam alerts. So here you're referring to phase 3 of the commissioning data?
Yeah, and in particular, right, because that's the, one of the sort of small surveys where we will be able to build references and take sort of realistic.
So we really cannot expect to get alerts that are younger than weeks in that phase?
Right.
Did I understand it right?
Yeah, we're not being encouraged to describe a faster process than that, just because it is still early commissioning at that phase. My hope is that during the mini surveys with full LSST camera, that we would be able to dial that down. But that's my own personal hope, rather than a policy.
So I'm going to make this case, which I know that you fully understand, but just for the sake of completeness in the call, I'm going to make this case that a lot of the interest in the transient science is specifically about young transients, so not getting the alerts soon, but getting them with weeks latency does not understand the community, does not allow the community to understand the potential of young transient discovery from LSST, and I know you're aware of that.
Yeah, I certainly do. I think the return argument is that the commissioning process is not about first and foremost getting achieving the science in real time, but about making sure the instrument and pipelines are commissioned, and that's difficult to do.
Fair point. Although my counterpoint is that we are also commissioning ourselves in commissioning phase, right? And so the transient community is commissioning themselves in the sense of how they absorb the output of the brokers and how they organize the follow-up, and all that is also time critical for us.
Right.
To get to science, to optimize science production in full observing phase.
Yep.
I rest my case.
All right, let me move on then and talk about the MiniBroker a little bit.
Actually, Eric, let me interrupt really quick and say, because this is a PST meeting, let me just reassure you that the point that you just made has been made emphatically around the PST table.
Great.
And I think the project well knows that, reducing that latency is a good thing. Fred, I think just what you're hearing is they're not willing to commit to things.
Yes, thank you.
Yes. All right, turning to the MiniBroker. Again, this is a simple service that runs on the LSST DAC and allows users to upload a simple filter that operates just on the alert packets and receives the output subject to some constraints. There are a lot of details here that I think are not fully resolved, and I'm going to poke at a few ideas here, and again, welcome your comments. We're still refining some of the design and requirements, and they sort of feedback against one another. So again, the idea is that the MiniBroker is only passing sort of a maximum about 20 alerts per visit, which is potentially still large, depending on exactly what kind of transients you're looking for. There's some question of whether that allocation could be pooled between users, and to what degree filters can be shared among users. I think my major statement at this point would be that we recognize that desire, and we'll try to enable it within the technical constraints that we find. So the formal requirements again are that we accept user-defined filters, and also we'll provide a predefined subset of useful things, which Fed maybe that's a future topic for TVS to interface with us on to give some feedback on what those might be. Again, we're providing up to 20 full alerts per user per visit, and describes up to 100 simultaneously connected users. This language is really coming out of a sort of an earlier vision for the implementation that was pretty heavily focused on VO event and VO event transport. It's not totally clear that those are the most relevant metrics today, but I'm not in a position to adjust those yet because we don't have a clear design replacement. There is no latency requirement for the MiniBroker, and so I think certainly we should expect that it will be, not more than hours. It's not going to be there's not going to be a week's latency out of the MiniBroker, but it certainly is not subject to the 60-second requirement we have for delivery to the community brokers. And that actually becomes relevant as we think about how to implement these user filters. It's not providing, firm science-driven classification. We're not going to say here's all the 1A supernovae that LSST found. We're not doing cross-matching, and there's language in the documents that in case of overwhelming demand, there may be a TAC-like process to sort of allocate this resource. That's true for many aspects of the science platform, incidentally, where you sort of have a baseline allocation, and then you can apply for more CPU time or other resources. So again, my personal goal is to make this as capable a service as possible to allow users to really get their hands on the stream.
Eric,
yep, go ahead, Fen.
There were a few things that I've heard, but they're probably just sort of rumors, but was that the MiniBrokers will provide 1% of the alerts, and a lot of questions that I got about that was, would that 1% be the same for all the MiniBrokers? Could you envision like a consortium of like 20 users that get 1%, and is that 1% random, so the 20 users effectively get 20%?
Right.
Is there any more detail about that?
Yeah, that's a good set of questions. So again, the requirement here is 20 alerts per visit, and the total number per visit is up to 10,000. So that's the scaling factor, and each filter is returning whatever passes its filter. So I don't know that. So it's not that we're just slicing a random 1% out and handing it to users. It's that the full stream goes into each filter, and the filter looks at each alert packet and says yes or no, yes or no. And then presumably, again, I think this detail is definitely not resolved. If you hit a capacity limit, say, it keeps a count of how many past alerts for this visit, then it, for example, truncates from there. So it's not clear that you could set up filters that would successfully combine into a larger capacity. You'd have to be pretty clever, I think. But again, I think there's a possibility that we could allow users to pool resources and so have a single filter that would be shared that might have a larger capacity. Again, that's not a guarantee. That's an idea.
Okay, thank you.
Yep. All right, so let's talk a little bit about interfaces to the MiniBroker. We're thinking about trying to tie this in with the rest of the tools provided by the Science platform, which has visualization, and user groups and permissions, and database storage, and so on. And so it'd be nice to be able to leverage these. We certainly know that one of the use cases for the MiniBroker is for sort of real-time follow-up, real-time streaming, triggering, and so we'll definitely provide a real-time interface so that a user could get alert packets that have passed through their filter on their own computing to do whatever they please with. I think unlike the full stream, where we have an argument that we need to sort of do a bulk transport system that meets our needs, here I think it's clear that we should provide whatever the current edition of VO event is, because the LSST project is adopting a VO first policy, and here the alert volumes are not high. So we will provide a VO event stream for MiniBroker output. We are going to be discussing the bulk transport scheme with the VO, and so it may be that these are so close as to be identical, but that's to be resolved. So the stream is one interface. It's also my feeling that there's an interesting use case of working with filtered output within the Science platform itself. So if someone doesn't necessarily want to have to listen all the time with their own computer to their filter, perhaps they could work within the Science platform itself. It's a little hard to tell exactly what the difference is between just querying the prompt products database whenever you want to find new sources. But I think in particular, the alert packets have quite a lot of contextual information. It would be nice to be able to, if it is a query-based workflow as opposed to a stream-based workflow, to at least be able to use those same sort of Python-type filters that access all of that information from the alert packet. So again, this is an area where I think there are some questions to be resolved. I'm also thinking about, to what extent we can enable or want the Science platform and the MiniBroker to be able to talk to other sort of channels in the larger, time domain science realm, everything from email through things like the transient name server. We have reporting mechanisms that exist that are external to LSST, and I could easily imagine someone who wants to be able to send their classifications that they've derived from into these channels. So it's not clear to what degree this is something that is a responsibility of the Science platform, but I think it's an area that's worth keeping an eye on. One limitation is that for working within the Science platform, you might want to sort of repeatedly run a job of some kind on your computing allocation, but it's not clear at the moment that users are able to schedule jobs as they would on their own servers, and so that may prove a limitation to sort of not real time, but sort of regular batched processing.
Eric, there's a question from Megan. Megan, can you ask it yourself, or do you want me to ask it? I don't know if she can. She's asking, it's hard for me to envision what a mini broker is compared to a broker. Can you give a more concrete potential use case for each?
Sure. There's a few different ways of this question. Let me walk through them in turn. At a technical and policy level, a community broker is receiving something like the full LSST stream, but it's running on hardware provided by an entity that's external to LSST. It's not controlled by LSST, the project. It is probably doing extensive cross-matching to other catalogs. It's perhaps doing some kind of generic classification, for instance, of alerts as they pass through, and perhaps providing, a sample of, high-quality supernova 1A that have been, classified using a very sophisticated light curve fitter, for instance. The MiniBroker is running in the LSST DAC. It is running small little filters that just look at the single alert packets. And so a user, for instance, might say, I'm interested in fast transients, so only show me packets from the deep drilling field that were not detected last night, but show a sharp change in magnitude within this night, and pass me those alerts, for instance. And so it's a much more sort of atomic view of the data, and really focused on sort of honing in on the specifics of an individual alert packet rather than putting it in context with other data sets or more complicated classifications. Does that get there, Megan? Okay.
Yes, she says it's good.
All right, just some near-term items. In May, several of us from Alert Production will go to the IVOA meeting in Victoria and describe some of these plans. I know there has been discussion recently about ongoing evolution of the VO event standard, and so we'll certainly bring our plans for that discussion. Again, in June, I intend to have this draft document for broader comment. You've seen the high points, but the details are important as well. As advertised, July we have a milestone for alert distribution, and I expect that we'll show that we can meet our requirements with the system we are building. And then in August, anticipating release of the broker policy document. So just again to summarize, I think we're on track for bulk alert transport. The MiniBroker system needs continued thought and discussion. We're trying to aggregate just because it influences our own technical development cycle, some of the process for choosing community brokers, and we're happy to take feedback on all of these items now or when the full document is ready later this summer. So thanks, and I'm happy to take more questions.
If there are more questions, I see them on the chat. Megan is asking, what if I don't need the alert stream info in lifetime, but I do want to collect and filter in the morning after, for example?
Right. Yeah, so that's exactly that sort of intermediate case that we're trying to figure out where you'd work in the science platform. So you can always go in the morning yourself and log in and query the solar system objects, for instance, which are, as we know, updated sort of not in real time, but sort of in a batch later. What's not clear at the moment is whether you could set up a little script or daemon to run in the science platform and flag objects for you automatically. That certainly would be a nice capability, but I don't yet know what the constraints are.
Right. So specifically, her question was about the limit of 20. If that could lift the limit of 20, sounds like.
Oh yeah, certainly for a direct query, there would not be a limit. That's really just for things passing through the real-time MiniBroker. But yeah, when you query the databases, you don't have that restriction.
The use case I'm thinking of, there will be lots of NEOs not yet flagged as solar system object and sent out as alerts. MOPS might take days. The NEO folks really want to be able to access the alert stream, but may not need it in real time. Yeah.
I hope MOPS does not take days. I'll suggest in this case that we maybe close the loop with Mario and talk through this in more detail since he's focused on that aspect.
Okay. Anybody else has questions? Everybody seems silent.
All right. Well, I'm happy to take any other thoughts by email. If you're in the shower tomorrow and think of something, you can always shoot it my way.
All right. Thank you very much. If there's nothing else, thank you very much for participating to the chairs. The notes were being taken in real time, so there's a link to those on Slack. As usual, we will make the recording of the talk as well as the slides available on the scientist webpage as soon as the LSST website comes back up. And we'll open a community page for discussion. Please discuss more on the community page. I would love to see those pages getting a bit more lively. Eric, can we share these with the science collaborations? Are there any restrictions on the slides?
I don't think so, but I might not advertise them too broadly since large parts are pretty preliminary still. Okay. It's no problem to post them, but I might not send an email to the whole world right away.
All right, so we look forward to hear updates as things evolve and if they change. And we look forward to seeing the documents, and I think I speak in the name of all the SC chairs. I'm happy that you guys want to share the document with the SC chairs before it goes out public. We're very, of course. I think we're all very eager to be able to provide feedback that way. Thank you.
Yep.
Thanks, everybody.
Thank you, Sergio.
Thanks, Eric.
Bye. Thank you.
Thank you.